Hi everyone and welcome to this video. So I thought it was about time I did a solar update. So I've been using solar every day pretty much. It powers my office workshop, and those of you who know the algorithm know that it's dependent on light and battery voltage. Generally speaking, if there's light it'll go off solar, if there's no light it'll go off mains. In a nutshell, that's how it works. So anyway, it's been working fine, but there have been a couple of little hiccups, and I'll just show you what those are now. First of all, if I just go over to the contactor, so you can see the contactor there, and there's a problem when this switches over from mains to solar or solar to mains. The contactor, and the relay as well, which controls the contactor, takes too long. And because it takes too long to switch over, my PC will switch off. So it'll switch off, and then it's sort of, I think it's either a brownout or a blackout. Basically means there's no power for an amount of time. So that's an issue which I need to resolve. So that's one issue. You can see here there's an amplifier, and that amplifier basically gets the voltage drop across this shunt resistor here, which then gets amplified. If I go back over here, it gets amplified and then fed into the ADC of the Arduino, and that's fine. You know, it sends it over and there's no problem. But I think that at the low end, I think it's not very accurate, and I think that if I was to use a new device which I've found, it's called the ADS 1015. If I was to use that, I think I would probably get better resolution and more accurate. So I want to do that, so I want to make an improvement there. Now the next issue is over here. You see the two wires which come from the node MCU to control two relays. That's a relay for the contactor and relay for the inverter. Well, they work, but as soon as you restart this little device, it won't boot up. And I think it won't boot up because there's certain pins, the 3 and 4 or whatever they are held low. And the node MCU, when those pins are held low, it just doesn't restart. I don't know exactly why, but that's what happens. So I ideally need to come up with some sort of solution for that too. So in a minute I'm going to go into my office workshop, and I'll tell you what my solutions are to fixing these problems, or possible solutions anyway. So we've got the contactor and relay problem, if you like. We've got the amplifier problem, and there's something there to do with restarting with the node MCU. Okay, so one of the main components of my entire solar panel system, and one of the most important, is the contactor. So in my solar panel system there are actually two contactors, and they're connected together with a mechanical interlock in the middle. I'll explain that in a second. But to start with, these contactors, what exactly are they and how do they work? Well, in the contactors there's basically a coil and 3 relays. Well, in my one there's 3 relays anyway, and of course in this one it's the same one. It's the same contactor. So what happens here is that the relays inside the contactors, they have a normally open position and a normally closed position. So the normally closed position, which is this one, when it says normally closed, by the way, that's the state without the coil being powered. So when the coil is not powered, in this particular setup that I've got, there's no mains connection. And likewise in solar, when the coil is not powered, there's no connection. It's completely dead. In other words, if neither of the coils are powered, there's no connection at all to the output over here. When the coil is powered, then the live neutral and earth from mains is connected to the output, and the same here. So if this coil is powered, then the live neutral and earth are connected to the 3 cables here, or 3 wires here, to the output. Now, both of these could technically, at the minute, touch, couldn't they? Live neutral on Earth could feed down here, and live neutral on Earth could feed down here, if both coils were powered. That's the way it works. But it can't do that. And the reason why is because I've got another relay here. And this relay either powers this coil or it powers this coil. And the armature can't power both coils, it can only power one coil. So it's either powering this one or it's powering this one. Now there's another reason why it can't, and that's because there's a mechanical interlock here. So basically, if one is powered, or if these are switched in a certain way, it locks the other one off. So if this one is powered, that can't be powered. And if this one's powered, that one can't be powered. So basically, that's the way the contactors work in my setup. So the reason I'm explaining this, well actually it's quite interesting to know anyway, I suppose, but the main reason I'm telling you is because I mentioned about a delay which is long enough to turn my PC off in my workshop. And that delay is because of these two issues, or these two things here. So when this armature moves from one to the other, of course, at some point, that is not going to be touching either of the connectors. And any time when that armature is not connecting either that one or that one, even if it's for a few milliseconds, is of course not powering the coil. And if it's not powering the coil, then these are not going to be connected to anything. So at the moment there's a point where when that moves there's no power whatsoever. And of course when there's no power whatsoever here, that's when the PC shuts off. So that's what I need to get round. So there are a couple of considerations and ways that we could possibly get around this. But this is the primary one that I'm thinking of. I can't really allow that to connect to that at any point, so it's reasonable to keep the mechanical interlock in place. So what I'm thinking is that this relay here, if I remember rightly, has, I think it's about a 20 to 40 millisecond delay when it switches from one to the other. And that's quite a long delay in terms of electronics. And it's probably an unacceptable delay too. So if I was to get rid of that, then we may get somewhere. Now if I was to switch the ground instead of the live, I could actually use a transistor, or a MOSFET. I could actually switch it on here, so I could have it connected to both here, connected to that and that at the same time, and put the transistor here somewhere, and the transistor, or the two transistors, could either let this one flow or let this one flow. So that's potentially one way to do it, but there's another way which I think may be easier. This is called a solid state relay, and they're extremely fast. So basically it's a relay without the mechanical bits. So it's an electronic relay basically, without the armature. Now I haven't gone into any depth with this little device, and I'm not going to in this video. I'll explain this little thing in another video, but that's how I'd get around it anyway. I'd use a solid state relay. So instead of the mechanical one, I'd use solid state. Now that solid state, I don't know the exact details, but I know it's massively faster than the mechanical one. So when this switches over from this one to this one, instead of having a 20 millisecond delay or 40 or whatever it is, it will be less. So therefore, the brownout or blackout will have less duration, and therefore the chances of my PC staying on will be better. So anyway, that's the solution, or that's what solution I'm going to put in place for that particular problem. So the other issue I said is about the amplifier. So from the shunt resistor to the amplifier, I said that maybe at the low side of the scale when it comes to a millivolt or 2 or whatever, it may not be that precise. So I'm going to try and use this. So this is the ADS 1015, and this is an ADC. It's not technically an amplifier, but it's a 12-bit ADC, and it's got a built-in gain control thing. So what it means is you can have much better precision in two ways. To start with, it's got an inbuilt gain thing, and of course 12 bits resolves to 4096 counts rather than the 10-bit one, which is 1024. So I'm probably going to use that too, and hopefully that will be really useful, and that will improve my system quite a lot. So that's the second problem. Now the third problem, I said that there were two wires, and the two wires, when the Node MCU restarts, it like blocks. It pulls the pins low and it won't let the thing restart. So what I'm thinking is that I probably use this instead. And I've done a video about this as well. This is the ESP32. So it's the basically the latest version of the Node MCU, and it's apparently much better. I've had a quick look at it, and it does seem a lot better. So yeah, about the pin issue, because there's a lack of pins or usable pins on the ESP8266 or the Node MCU, I'm thinking of just replacing it with this, and hopefully there'll be more usable pins on this device. So there you go. So that's my plan. That's the current. They're the current problems, and that's how I'm hoping to deal with it. So I hope you liked the video, and thank you for watching. Bye.